Okay, so this is the solution to the problem range addition 2. It's an easy rated problem hinging on one single observation, and that's it. We'll get to what that is, but first let's understand this question with an example. You're given a matrix of size m cross n, initialized with all zeros. In this case, m and n were both 3, so it's a 3 by 3 matrix with all zeros. You're also given a list of operations. Now each of these operations specifies the endpoints. So 2, 2 is one particular endpoint. The starting point of any operation is going to be 0, 0 always. Now the operation itself says that starting from 0, 0, ending at 2, 2, go ahead and increase everything covered in that box by 1. And so that is why you see 1s here and 0 remains as is undisturbed. What if we have the operation 3, 3? In this case, what you're going to do here is start from 0, 0, end at 3, 3. Everything in the middle gets increased by 1. And we're almost done. Now the question asks, find me what the greatest of these integers is. Between 1 and 2, we can look at 2 as the biggest integer. We'll keep that in mind. And the question says, of the biggest integer, count how many times it occurs in this entire matrix. In this case, the answer is 4, and so we'll return 4. Now this is fine, but let's discuss one edge case where there are no operations at all. What if this list was empty? In the case this list was empty, you'll just have this 0 by 0 matrix of 3, 3 matrix of all zeros. And what is the greatest integer of all of them? 0. And what is the count of that integer? It's 3 times 3, or in general case m times n. And so if not ops, return m cross n. Easy. Now we'll discuss a more abstract case which will clarify everything this question ever needs. First, let's discuss this. This is like a giant 0 by 0 matrix. Could be square, could be rectangle, that does not matter right now. Let's have this as one particular box. The operations will give you the point, this point, and we'll go ahead and increase everything in the blue by 1. That's fine. So there are a bunch of zeros here and bunch of ones inside of this blue shaded region. Now what about this orange part? As soon as we include that, we'll notice something. All of the region between orange and blue both is going to give you a score of 2. And the score of 2 is actually what we want. So if we were to stop at this point, what would be the answer? We can just look at what this end point right here is of this rectangle, of this orange rectangle, and we can do some computation based on that, because we know that all of there are 2's instead inside of this intersection. Okay, what if I make things a bit more complicated by introducing this green section? Now what can we observe? Well, while this green section on its own is going to give you a score of 1, this green and blue intersection gives you a score of 2. All of these colors intersecting, the blue, the orange and the green, will give you a score of 3. And what's so special about this 3? This 3 is the highest integer because it's sitting at the intersection of every single rectangle. And now I want to ask the second question. I know that 3 is one possible answer, that's fine. But 3 isn't what's required. In this case, 2 wasn't the necessary part. The necessary part was looking at this 4 right here, which is the count of these guys. Look at what happened back then. We had this giant square and this other square intersecting inside of it. And so what was the answer? It was this operation's multiplication. It was 2, 2 multiplied. Basically, there were 4 2's in here. What is going to happen in this case? Well, we know for a fact that intersection of blue, orange and green is going to give you a score of 3. And we know that this nice little cute little square has the answer 3. And now we'll want to just calculate what's this ending special point here. Okay, how do you find that? If you look at it, It's just a product of the minimum of all the possible x's and the minimum of all the possible y's. And that is it. Feel free to pause and take a wild guess about why that could be, but it's going to be the minimum of all the x's and minimum of all the y's. And so we'll actually code this up. We'll have a capital X and capital Y representing two values, and we'll iterate over operations and this, and we'll have x equals to the minimum of x and the current x. So we'll actually put it x comma y in. We'll have the y similarly as the minimum of whatever y was, and if you can give me a new y which is lower, at the end returning x times y. And this is it for the solution of the problem range addition 2. Cool, thanks for watching.